located on one of the most seismically active regions on Earth, where tsunami waves reaching nearly 40 meters once claimed the lives of more than 18,000 people. Japan was forced to create an unprecedented engineering marvel, building a Great Wall stretching nearly 400 kilometers to protect the future of an entire nation. This is not only the country's final line of defense against the ocean, but also an effort to safeguard an agricultural system that produces millions of tons of crops every year. So, how did Japan build a Great Wall powerful enough to withstand gigantic tsunami waves? Join Agriculture Insight as we uncover the story behind this extraordinary achievement. The paradox of Japan is that the very advantages that created its prosperity have also become its greatest vulnerability. Surrounded by the ocean and blessed with more than 35,000 kilometers of coastline, Japan has been forced to concentrate most of its population, major cities, seaports, industrial zones, and its most fertile plains along the Pacific coast. Yet this same coastline sits at the convergence of four major tectonic plates, making it one of the most seismically active regions on Earth. Whenever the seafloor is displaced by a powerful earthquake, the entire column of water above it is pushed upward, generating tsunami waves capable of traveling at speeds of nearly 800 kilometers per hour. As they move into shallow coastal waters, the waves rapidly increase in height, transforming into enormous walls of water that surge directly onto the land. That is why Japan has repeatedly suffered some of the most devastating tsunamis in the world. The disaster in 2011 alone claimed the lives of more than 18,000 people, destroyed more than 123,000 buildings, and triggered the most severe nuclear crisis since Chernobyl. Total economic losses exceeded $220 billion, making it the costliest natural disaster in modern history. But that was not the only price Japan had to pay. With only about 12% of its land suitable for cultivation, every major tsunami devastates precious coastal plains while threatening the limited farmland that feeds the entire nation. Instead of simply responding after disasters, the Japanese turned adversity into a catalyst for innovation, building one of the most advanced disaster defense systems in the world. So how can this Great Wall, stretching nearly 400 kilometers, protect millions of people, safeguard agricultural regions that produce millions of tons of crops every year, and defend the world's fourth largest economy? To understand this extraordinary achievement, we must first go back to the moment when Japan decided to do what many believed was impossible. The first step was to create the most detailed tsunami risk map ever developed. Engineers gathered dozens of layers of data, including records of earthquakes and tsunamis spanning centuries, seafloor topography, ocean depth, the shape of coastal bays, shoreline gradients, and the locations of cities, seaports, industrial zones, and critical agricultural plains. This information was then fed into hydrodynamic models running on supercomputers. Instead of simulating a single scenario, the system calculated thousands of different possibilities. Based on these simulations, engineers determined the height, length, location, structural design, and level of reinforcement required for each section of the wall, ensuring it is tailored to the terrain and tsunami risk of every coastal area. In other words, Japan's Great Wall was not built to follow the coastline. It was built to follow the path of risk. For Japanese engineers, the first enemy was not the tsunami, but the unstable coastal ground itself. After thousands of years of sediment deposition, many coastal areas were formed from sand, mud, and soft sediments that could not support the enormous weight of massive concrete seawalls. In areas with weak ground conditions, reinforced concrete piles or steel piles measuring between 20 and 40 meters in length were driven or drilled into stable soil layers, transferring the entire load of the wall to the foundation below. In many locations, the ground was further reinforced with crushed stone, geotechnical materials, or advanced soil improvement technologies to reduce settlement and prevent soil liquefaction during earthquakes. Only after the foundation was strong enough could construction of the tsunami seawall truly begin. Instead of pouring concrete continuously along the entire length of nearly 400 kilometers, engineers divided the project into thousands of independent sections. This allowed construction to proceed simultaneously at multiple locations while limiting the impact if any section were damaged in the future. First, reinforced steel cages were assembled directly at the construction site and positioned on the completed foundation system. Next, high-strength concrete was continuously pumped into the formwork using specialized concrete pump trucks. Every layer of concrete was mechanically vibrated to remove air pockets, increase density, and minimize cracking after curing. Once the concrete reached its designed strength, the individual sections were connected to form a continuous defensive barrier. Depending on the terrain and the level of tsunami risk, the wall ranges from 5 to 15 meters in height, while its foundation is anchored as deep as 25 meters below the surface. The base of the wall is also significantly widened to distribute structural loads, resist overturning and sliding, and reduce erosion under the immense force of tsunami waves. However, the purpose of the wall is not to defeat the ocean. In many locations, additional layers of large armor rocks, wave-dissipating concrete blocks, and reinforced sloped embankments are installed in front of the wall. These structures absorb part of the wave's energy before it reaches the seawall itself, while also reducing foundation erosion and extending the lifespan of the entire defense system. Interestingly, the Japanese have never considered the Great Wall to be their only line of defense. If a tsunami powerful enough were to strike, no wall could guarantee stopping millions of tons of water rushing toward the land. Instead of trying to conquer nature, the Great Wall is designed to slow it down. By reducing the height of the waves, absorbing part of their energy, and delaying their arrival by just a few minutes, the early warning system gains enough time to issue alerts, evacuation routes can be activated, and millions of people have a chance to escape the danger. That is why, behind the wall, an entire network of seismic sensors, wave monitoring buoys, warning sirens, and evacuation routes operates as one unified system. But the greatest value of this defensive barrier is not the wall itself. It is what the wall protects behind it. It protects Japan's limited coastal plains, which produce millions of tons of agricultural products every year and help sustain one of the most productive agricultural systems in the world. With about 80% of its territory covered by mountains, Japan has only about 12% of its land suitable for cultivation. Most of this limited farmland is concentrated on fertile coastal plains, the very areas that face the constant threat of earthquakes and tsunamis. That is why every square meter of land behind the Great Wall carries extraordinary importance for the nation's food security. Among these precious resources, rice has always been regarded as Japan's second line of defense. During harvest season, GPS-guided combine harvesters automatically move through the rice fields with an accuracy of just a few centimeters, cutting, threshing, and cleaning the grain in a single operation. This highly mechanized process speeds up harvesting, reduces crop losses, and preserves grain quality before the rice is dried, milled, and sorted. Every year, more than 1.4 million hectares of rice paddies produce approximately 7 to 8 million tons of rice, supplying the primary food source for more than 120 million people across Japan. Unlike many countries that can expand their agricultural land, Japan has virtually no additional farmland to replace its coastal plains if they are devastated by tsunamis or contaminated by saltwater. In a country where expanding farmland is almost impossible, the value generated from every square meter matters more than total production. And Wagyu is perhaps the clearest example of that philosophy. With limited land available for livestock farming, Japan does not compete by raising larger cattle herds like the United States or Brazil. Instead, the country focuses on genetic selection, herd management, and quality optimization to produce one of the world's most valuable types of beef. For approximately 28 to 36 months, the cattle are fed carefully formulated rations consisting of hay, rice straw, corn, barley, and various energy-rich grains. This controlled feeding program regulates growth while encouraging the formation of the fine marbling that develops throughout the muscle. The extended feeding period creates Wagyu's signature tenderness, rich flavor, and its world-famous melt-in-your-mouth texture. For Japan, Wagyu is far more than just beef. It is a multi-billion-dollar industry with a domestic market worth nearly $11 billion and annual exports exceeding $400 million, making Japan the global leader in the premium beef segment. Even after protecting its land from tsunamis, Japan still faced another major challenge: too little farmland and an increasingly aging agricultural workforce. Instead of expanding agricultural land, the country chose to increase productivity on every square meter through high-tech greenhouses. Today, Japan operates approximately 43,200 hectares of greenhouses, producing a large share of the nation's premium vegetables, fruits, and flowers. Transparent glass panels and advanced polymer materials maximize the use of natural sunlight, while automated shading, ventilation, heating, and cooling systems continuously regulate temperature and humidity to maintain optimal growing conditions throughout all 4 seasons. Many greenhouses also incorporate hydroponics, fertigation, and autonomous robots for planting, harvesting, and transporting crops. As a result, water consumption can be reduced by as much as 70 to 90%, while productivity per square meter is many times higher than that of open field farming. Inside these facilities, premium melons, strawberries, tomatoes, and leafy vegetables are produced year-round with highly consistent quality for both domestic and export markets. One of the most remarkable examples is the Bijenheim strawberry, one of the most expensive fruits in the world. After more than 15 years of breeding, only about 500 strawberries meet the standards for sale each year, with prices reaching as high as $500 per fruit. What Japan is selling is not just a strawberry, but years of breeding research, precision greenhouse technology, and nearly perfect quality standards for size, color, aroma, and sweetness. From rice and Wagyu to high-tech greenhouses, they all share one thing in common: they depend on the limited land that Japan must protect at all costs. No wall can completely defeat a tsunami, but by buying even a few precious extra minutes, Japan's Great Wall helps protect its people, its farmland, and one of the highest value agricultural systems in the world. Carrying the burden of rebuilding many of Japan's coastal communities after the devastating 2011 tsunami, mussels are far more than just seafood to the Japanese. They are a source of livelihood for thousands of families, generating more than $4 billion in economic value each year. Unlike countries such as the Netherlands, France, and the United States, where shellfish are often dredged directly from the seabed or cultivated in nearshore cages, Japanese mussels are raised on massive suspended longline systems in some of the most nutrient-rich waters on Earth. Fueled by the convergence of the warm Kuroshio Current and the cold Oyashio Current, thousands of mussels densely cover each rope within just 12 to 24 months, requiring virtually no industrial feed. When harvest season arrives, specialized vessels move along the farming lines and use hydraulic winches to haul the mussel-laden ropes from the sea onto the deck. There, the ropes pass through mechanical stripping systems, where continuously rotating rollers remove thousands of mussels in just minutes. The harvested mussels then flow onto conveyor belts and into enormous collection bags, ready to be transported to processing facilities. Once they arrive at the harbor, the mussels are transported directly to processing facilities, where they undergo a series of rigorous cleaning procedures. They pass through multiple washing tanks, high-pressure water spray systems, and rotating mechanical drums designed to remove mud, sand, seaweed, and other organisms attached to their shells. This step is particularly important because mussels are filter feeders, making them highly susceptible to retaining impurities from the surrounding seawater. After being sorted and inspected for quality, the mussels are either packaged fresh or further processed through a series of value-added operations, including steaming, meat extraction, vacuum sealing, and flash freezing. The finished products are then distributed to supermarkets, restaurants, and export markets around the world. Often referred to as the white pearl of the ocean, scallops generate approximately $3 billion in annual revenue and rank among Hokkaido's most valuable seafood products. Like mussels, their journey begins at sea. However, instead of growing in dense clusters along cultivation ropes, individual scallops are suspended separately in multi-tiered cage systems. This approach reduces competition and provides each scallop with sufficient space to develop evenly. Throughout their growth cycle, nutrient-rich cold currents continuously flow through the cages, delivering a steady supply of natural food and helping form the thick white adductor muscle that ultimately determines the premium market value of Japanese scallops. When harvest season arrives, hydraulic cranes lift cultivation lines stretching tens of meters from the sea, revealing thousands of scallops densely attached like a fully assembled production chain. The scallops are quickly removed on deck, rinsed with seawater, and transported directly to processing facilities within just a few hours. From this point onward, the process shifts into a tightly controlled operation. High-pressure water jets operating at 5 to 6 bar thoroughly clean every groove of the shell before the scallops are shucked while still alive to extract the prized white adductor muscle with maximum precision. The meat is then washed, graded, and subjected to rapid freezing at -40°C, locking in its texture and natural sweetness. By the time packaging is complete, each tray of scallops represents far more than seafood. It is the product of a seamless production chain, one in which the ocean does not merely provide the resource, but actively contributes to every stage of value creation. Leaving behind the scallop farms beneath the ocean, we arrive at Ariake Bay, where seaweed not only forms the soul of Japanese sushi, but also supports a nori industry worth more than $1 billion annually. In Japan, seaweed is cultivated on vast marine farms stretching across coastal waters. Although it shares the same origin as Korean gim, nori is produced with a fundamentally different philosophy, preserving its natural flavor rather than masking it with seasonings. Around November, when seawater temperatures fall below 12 degrees Celsius, nori enters its most vigorous growth phase of the year. As harvest season begins, the enormous cultivation nets that have remained submerged beneath the surface are gradually lifted by specialized vessels, revealing vast walls of seaweed stretching across the ocean. As the harvesting vessel moves along the cultivation nets, rotating blades spinning thousands of times per minute carefully trim only the upper portion of the seaweed, leaving approximately 5 centimeters of living base intact so it can regenerate for the next harvest. As a result, This is no longer a simple extraction process, but rather the management of an underwater crop, where each harvest marks the beginning of a new growth cycle. Immediately after leaving the cutting system, the freshly harvested seaweed is compressed into mesh bags, weighing up to nearly 1 ton, and transported ashore as quickly as possible to preserve its quality and freshness. At the processing facility, the seaweed passes through large-scale recirculating washing systems designed to remove sand, sediment, and other impurities. What surprises many people, however, is that the journey from fresh seaweed to a finished sheet of nori is not quite what they imagine. Rather than being dried whole, the clean seaweed is finely chopped and processed using a method remarkably similar to papermaking. The resulting slurry is spread onto molds, pressed into thin layers, and continuously dried to produce nori sheets with uniform thickness, color, and texture. From there, the sheets are transformed into the finished nori products familiar to consumers around the world. The thin layers of seaweed found in countless bento boxes, sushi rolls, and rice rolls enjoyed every day across the globe. Looking like a pineapple that lives beneath the sea, sea squirts are both one of the ocean's natural biological filtration systems and a high-value delicacy, generating tens of millions of dollars annually for Japan's coastal aquaculture regions. While nori requires only a few weeks to grow and mussels typically reach market size within 1 to 2 years, Japanese sea squirts demand a much longer cultivation period of 2 to 3 years. The process begins when juvenile sea squirts are attached to suspended cultivation ropes beneath the sea, where they firmly anchor themselves and gradually grow through multiple cold water seasons. Because of this lengthy waiting period, every harvest carries special significance. When the season arrives, specialized vessels travel along cultivation lines stretching hundreds of meters and use hydraulic winches to continuously lift rope after rope, densely covered with sea squirts from the ocean onto the deck. Immediately afterward, the sea squirts pass through specialized separation machines, where continuously rotating rollers remove each cluster from the cultivation ropes. The freshly harvested sea squirts are then quickly loaded onto the vessel and transported ashore to preserve maximum freshness. Before reaching processing facilities, workers sort the harvest, cut individual sea squirts from their attachment stalks, and thoroughly remove seaweed, sediment, and other organisms clinging to the outer surface. Following this initial cleaning stage, the sea squirts are rapidly distributed to restaurants and processing facilities. Beneath their rough, spiky exterior lies a bright orange flesh renowned for its rich sweetness, distinctive ocean flavor, and unique balance of crisp and tender textures. In Japan, sea squirts are commonly served as sashimi, seafood rice bowls, or grilled dishes, making them one of the most sought-after marine delicacies in many coastal regions. Consuming nearly 80% of the world's sea urchins, Japan has transformed these spiny creatures of the seafloor into a high-value industry, where the prized uni inside can sell for as much as $500 per kilogram. To harvest this soft gold, divers must descend to the ocean floor, where black and purple sea urchins cling tightly to rocks, concealing one of the most sought-after delicacies in Japanese cuisine. Equipped with little more than a mask, thick gloves, and a small metal hook, divers carefully search meter by meter across the seafloor, weaving through underwater forests of swaying kelp in search of the largest and most mature sea urchins. At times, the job feels more like a treasure hunt than a fishing operation, because the true value lies not in the creature's spiny exterior, but hidden deep within its shell. Every reach of the hand is a test of experience. A single careless movement can damage the delicate uni inside and significantly reduce its market value. Yet the greatest challenge is not the sea urchin itself, But the ocean. Strong currents, cold temperatures, limited visibility, and a finite air supply turn every dive into a race against time. The reward, however, can be substantial. A skilled diver may harvest several hundred sea urchins in a single day, helping transform these spiny creatures into one of Japan's most valuable seafood industries. As soon as they reach shore, the sea urchins are transported directly to processing facilities, where workers use specialized scissors to cut through the hard, spiny shells and carefully extract each lobe of uni with small spoons. Every movement must be executed with absolute precision, as even a minor scratch can significantly reduce the product's value. After cleaning, the finest pieces of uni are hand-arranged into trays before making their way to premium sushi counters. Without wings or bones, yet capable of launching itself from the ocean surface and gliding up to 30 meters at speeds approaching 40 kilometers per hour, Totorodes pacificus is the famous flying squid that helps generate billions of dollars annually for Japan's squid fishing industry. For many coastal communities, it is a vital source of livelihood, which is why every year from June to November, thousands of squid fishing vessels illuminate the waters around Japan, creating one of the country's most vibrant and economically important fisheries. Squid fishing vessels typically leave port in the late afternoon, but the real hunt does not begin until darkness blankets the sea. Unlike many fisheries that must actively pursue their catch, Totorodes pacificus is naturally attracted to light. Taking advantage of this behavior, the Japanese have developed a harvesting method that has become almost a national symbol: light-based squid fishing. On vessels ranging from 30 to 60 meters in length, hundreds of high-powered lamps are switched on simultaneously, transforming the surrounding waters into a brilliant band of light across the ocean. Beneath this glow operates one of the most distinctive automated fishing systems in Japan's seafood industry. Hundreds of illuminated artificial jigs move continuously up and down in synchronized motion, while sonar and advanced detection equipment scan waters 50 to 150 meters deep to pinpoint the exact location of squid schools. Once the squid gather near the surface, the entire system shifts into full operation. In just a few hours, a single vessel can haul aboard between 1 and 3 tons of squid, and even more on particularly productive nights. Only hours after leaving the ocean, the squid arrive at processing facilities where they are cleaned, eviscerated, flash frozen, and packaged in a race against time to preserve the exceptional freshness carried in from the night sea. Breaking through snow layers up to 10 meters thick, and even over 20 meters on the highest mountain roads of Japan, Switzerland, Canada, and Alaska, USA. These giant snowblowers are the true path openers of winter, keeping transportation from freezing under an endless sea of white. At the front, massive augers and steel blades spin at incredible speeds, crushing and lifting thousands of tons of snow each hour, then blasting it through a huge chute with such force that it can be thrown over 40 meters away. A 700 horsepower diesel engine allows the machine to push forward through ice and wind, while a system of precision sensors and hydraulic controls automatically adjusts the intake height to avoid damaging the road surface below. Thanks to high-precision mechanization, these machines can operate continuously in conditions of near-zero visibility, enduring fierce winds and sub-zero temperatures, in places where humans simply cannot reach. If your field is covered with stubborn rocks, this rock picker machine is the ultimate solution, designed to clean the soil faster, smoother, and with far less manual effort. At the front, sharp steel teeth dig through the surface, lifting and collecting stones weighing hundreds of kilograms without disturbing the soil structure beneath. Its powerful hydraulic system sorts and unloads the rocks within seconds, leaving a clean, level field ready for planting. With the capacity to handle 3 to 4 tons of material per minute, this compact yet powerful machine replaces dozens of workers while protecting other farming equipment from damage throughout the next growing season. On vast pastures, rice fields, and vineyards, the Kuhn manure spreader unleashes a powerful nutrient rain. Mounted behind a tractor, its massive twin-axle system can carry up to 20 tons of composted manure. As the hydraulic gate opens, the material is fed into the spinning beaters at the rear. In an instant, a golden mist rich in nutrients spreads evenly across the soil, reviving its vitality and fertility. With a reinforced steel body and a durable drive system, this machine frees farmers from the backbreaking, smelly, and dusty work of manual spreading, while reducing transport trips by up to 5 times compared to traditional methods. Say goodbye to the days of slow, backbreaking grass gathering. These giant rotary rakes are engineered to collect massive volumes of forage after mowing, forming perfectly even windrows ready for baling with unmatched precision and speed. With 4 rotors measuring over 3.8 meters in diameter and a working width of up to 19 meters, this machine can rake up to 20 hectares per hour, far surpassing conventional equipment. Its flexible steel tines gently comb through the field, collecting every strand of grass without picking up soil or stones, preserving cleanliness and nutritional value. A hydraulic suspension system automatically adjusts rotor height, ensuring peak performance even on uneven terrain, allowing European farmers to complete the harvest phase with remarkable speed and precision. Handling grass bales weighing nearly 1 ton in less than 2 minutes, the Krone Comprima Extreme is one of the most advanced assistants for farmers in Germany, the Netherlands, and Northern Europe, where large-scale dairy farming demands thousands of tons of feed reserves each year. At the front, a hydraulic compression system with a pressure of over 120 bar tightly compresses the dried grass into a perfectly round shape, while the baling chamber rotates continuously to ensure even density. Immediately afterward, the rear turntable automatically transfers the bale to the wrapping stage, covering it with 4 to 6 layers of airtight plastic film, creating the ideal anaerobic environment for natural silage fermentation. Owning this machine requires an investment of around USD 100,000 to 150,000, a significant figure, but one that is well earned by its unmatched power and efficiency. Across the bright orange pumpkin fields of October, the global peak harvest season, the massive Tumoba pumpkin harvesters begin to roll. Each machine can harvest over 1 hectare per hour using its synchronized cutting heads and conveyor belts to gently lift, cut, and load tens of thousands of pumpkins in a single shift without bruising, preserving their perfect shape. Every year, more than 28 million tons of pumpkins are harvested worldwide, with China, India, and Ukraine leading global production, while the United States is the largest consumer, using over 1.5 million tons annually. To meet the global demand of more than 70 million tons of cabbage each year, European farms are accelerating efforts to optimize every stage of the harvest. At small and medium-sized farms, a semi-automatic harvesting method is now widely used, a major step forward from traditional hand-picking. Farmers cut each cabbage by hand, trim away the outer leaves, and place it onto a moving conveyor belt. This method is labor-intensive, but delivers high precision and minimal damage, ideal for export markets that demand consistent size and flawless appearance. In contrast, at large-scale farms in the Netherlands, Germany, and Poland, where yields reach thousands of tons per season, fully mechanized cabbage harvesters have become the industry standard. At the front, a system of rollers and cutting discs gently lifts each plant and slices it cleanly at the base. The cabbages are then carried onto a central conveyor, where workers simply inspect and remove any damaged heads before packaging. Each machine can harvest 8,000 to 10,000 cabbages per hour, cutting labor costs by up to 70%, while keeping the supply chain running smoothly throughout the season. This gradual shift from manual labor to controlled automation shows how European agriculture is moving toward a perfect balance between productivity, efficiency, and quality, where people and technology work hand in hand across the fields. On post-harvest or deforested lands where the soil is compact and uneven, this spike wheel cultivator becomes the leading tool for land restoration. Each steel wheel, over a meter in diameter, rotates continuously, breaking up hardened layers, uprooting roots, and clearing debris from the surface. Pulled by a high-horsepower tractor, the entire disc assembly can process dozens of hectares per day, leaving the soil loose and aerated for the next playing stage. This technology helps farmers save up to 80% of soil preparation time, while reducing the need for deep plowing, minimizing erosion, and preserving natural soil moisture, a major advancement toward sustainable modern agriculture. From September to October each year in Ukraine, Russia, Argentina, and the United States, when vast sunflower fields dry and bow in the autumn wind, the harvest season officially begins. At the front of each harvester, a specialized cutting header with dozens of steel teeth skillfully separates the stalks and feeds the flower heads into a high-speed threshing drum. Inside, the seeds are stripped clean from their heads, while powerful air currents blow away husks and dust, and vibrating sieves sort out uniform, glossy black sunflower seeds. When the grain tank fills, an automatic auger unloads a flowing stream of seeds into a trailer moving alongside, keeping the operation continuous and uninterrupted. Each machine can harvest 5 to 7 tons per hour, helping the world produce more than 55 million tons of sunflower seeds every year. Yet, the price of this massive efficiency is growing concern over fine dust, emissions, and noise pollution that spread across rural landscapes. To produce 1 liter of sunflower oil, about 2.5 to 3 kilograms of seeds are needed, processed through a heat pressing method that maximizes yield but destroys much of the vitamin E and unsaturated fatty acids, and can generate free radicals if overheated. In the past, harvesting 1,000 hectares of silage corn required hundreds of workers and took several weeks. Today, with the support of high-capacity forage harvesters such as the Krone Big X, John Deere, or Claas Jaguar, that enormous workload can be completed in just a few days. Each machine can easily process over 400 tons of corn per hour, equivalent to 20 to 30 times the manual labor productivity of the past. This record-breaking performance is achieved thanks to cutting blades spinning at over 1,1200 revolutions per minute, a hydraulic compression system, and a chopping drum up to 800 millimeters in diameter, which shreds the entire stalk, leaf, and cob into uniform particles. It's not only faster, but also more precise and consistent, thanks to smart sensors that continuously adjust cutting length, moisture, and throughput in real time. This exceptional optimization has driven the rapid expansion of modern dairy farming, which is increasingly scaling up in size and efficiency, with both herd numbers and milk production tripling since the 1990s. Out in the field, the Ropa Mouse 6 emerges like a giant, transforming beast. In just minutes, its colossal conveyor arms unfold like wings, rollers and hydraulics come alive, and the machine transforms into a towering monster capable of devouring entire mountains of sugar beets. At the front, a set of rotating rollers and sweeping paddles continuously scoop beets from massive piles onto the conveyor. Instantly, they pass through a series of rollers and high-speed brushes that strip away soil, stones, and leftover leaves from the harvest. With a processing capacity of up to 1,500 tons per hour, the Ropa Mouse 6 turns what once seemed a tedious task into a powerful, precise, and seamless operation. And of course, to own this gentle giant, a farmer must spend more than $560,000. Pulled by a John Deere crawler tractor with hundreds of horsepower, every rotation of this wheel of destruction can rip out massive roots as thick as a man's leg, grinding them into fragments mixed with the soil. Dozens of razor-sharp steel teeth mounted around the wheel dig deep into the ground, crushing old stumps, tangled roots, and even hardened earth. In just a few hours, a rugged landscape full of roots and obstacles is leveled into soft, workable soil, ready for cultivation or construction. This unusual machine is a deep soil aerator, capable of digging and loosening the ground down to 90 centimeters, an impressive depth compared to conventional plows. It is specially designed for fields that have turned as hard as concrete after years of farming or neglect. As it operates, massive steel tines penetrate straight into the soil, breaking up compacted layers and opening air and water channels. This allows new crops to develop deeper roots, absorb nutrients more efficiently, and restores vitality to the field. Next, we encounter a remarkable machine on the vast grazing fields, the barbed wire fence machine, a specialized device designed to replace manual labor that used to be time-consuming and extremely dangerous. In the past, stretching each strand of wire and driving every wooden post required many workers and several days. Today, a single person can complete an entire project stretching for kilometers. Its structure includes a vertical reel system that feeds barbed wire, which is then pulled tight and positioned precisely with the help of hydraulic arms. At the front, a hydraulic crane is equipped with an automatic post driver. Each strike delivers a force of up to a ton, powerful enough to drive a wooden post 0.6 to 1.2 meters deep into hard ground within seconds. Everything happens fast, neat, and accurately. With the support of this technology, farmers not only save thousands of labor hours, but also ensure fences that are strong, perfectly aligned, and highly effective in protecting pastures and livestock. This is not a doomsday machine from a science fiction movie, but rather a flame weeder, an organic technology that helps farmers eliminate weeds without chemicals. Large gas tanks mounted on the tractor feed fuel to a row of burners stretching across the rear. As it moves, powerful flames sweep over the ground, rapidly heating weed cells until they are destroyed within seconds. Unlike traditional field burning, this method is highly controlled. The fire targets only the weeds without harming the soil or the main crops. However, while this method has the advantage of being eco-friendly, organic farm compatible, and leaving no toxic residues, its drawbacks include high fuel consumption, limited efficiency on very large fields, and the risk of fire spreading if not carefully managed. Hemp, an ancient crop that has been cultivated by humans for thousands of years, is now making a strong comeback as a green solution for the future. With ultra-strong fibers, nutrient-rich seeds, and the potential to replace plastics, paper, and even construction materials. Across these endless green fields, massive hemp harvesters emerge as the beating heart of modern agriculture. At the front, razor-sharp headers slice cleanly through dense stalks towering 3 to 4 meters high. Instantly, the conveyor system pulls the stems inside, where they are cut, gathered, and transferred directly into the trailing wagons, forming a continuous flow. One version that takes hemp harvesting to a new level is the Hyler hemp harvester, a specialized machine that overcomes the shortcomings of earlier forage-style harvesters. Its dual cutting and gripping system allows the machine to harvest the seed-rich tops while neatly laying the sturdy stalks in long rows across the field for retting and fiber processing. In a single pass, farmers can collect both seed and fiber, preserving quality while minimizing post-harvest losses. Thanks to this technological leap, more than 300,000 tons of hemp each year can move swiftly from field to factory, ready to be transformed into textiles, nutritional oils, or eco-friendly biocomposites. To harvest bunches of celery that are juicy, delicate, and perfectly straight, farmers in leading producing countries such as the United States, Mexico, Spain, and China must put in tremendous effort. That is why the celery harvesting aid machine was created. A perfect blend of human precision and mechanical support. In the field, the front conveyors move slowly through rows of vibrant green celery. Workers cut each stalk by hand and gently place it onto the belts. Instantly, the celery is carried to the central platform, where other workers trim the base, remove excess leaves, bundle the stalks, and stack them neatly into plastic crates. The entire process unfolds like a living assembly line right in the middle of the field, from standing plants to neatly packaged bunches in just seconds. With this machine, farmers reduce the back-breaking labor while achieving yields of tens of tons per day, meeting the enormous demand of markets worldwide. Gone are the days when farmers bent their backs to lay every meter of plastic mulch by hand. Today, a single machine can cover an entire field with low tunnels in the blink of an eye. This is the low tunnel mulching machine, a specialized tool designed to protect tender crops like vegetables, strawberries, and melons. At the front, massive rolls of plastic film slowly unfurl. Instantly, the wheels press the edges firmly into the soil, holding the cover tight against the wind. Overhead rollers skillfully lift the film into graceful arches, creating endless rows of miniature tunnels. Beneath this transparent layer, the soil retains warmth, moisture stays balanced, and young plants are shielded from frost and pests. This method has been widely adopted in the United States, Spain, Japan, and China, where farmers save 150 to 200 hours of manual labor per hectare. In just seconds, massive banana stalks as thick as a leg are shredded into tiny fragments. This is the banana stem shredder, a specialized machine that helps farmers handle banana residues quickly and efficiently. As it operates, the giant rotating drum at the back, lined with razor-sharp blades, spins at high speed, pulling in the enormous stems, leaves, and sheaths. The resulting organic mulch is far from waste. It becomes a valuable source of green fertilizer. Returned directly to the field, it improves soil structure while providing nutrients for the next crop. This eco-friendly solution not only saves farmers the labor of clearing residues, but also reduces the cost of chemical fertilizers, creating a closed-loop cycle in banana cultivation.